Hi, this is Justine, and I'm going to be talking about misleading graphs. So here are 4 ways that a graph can be misleading. 1, starting a scale with a number other than 0. I'm also going to expand this to having an irregular scale where the numbers are not evenly spread apart in value. Our second point is going to be the complete absence of a scale, where we cannot compare what we see on the graph to any numerical value, and therefore we don't know really what's going on with it. And next, we're going to deal with bars of different width. Our eyes, we like seeing things similarly so that we can compare them easier. And when bars in a bar graph are different widths, our eyes kind of want to go with, oh, I see something that's bigger, I'm going to call it bigger, even if it may or may not be. And then for our last characteristic that we're going to talk about with a misleading graph is having a 2D graph with a section pulled away for emphasis, and often this means that that section is like blown up out of proportion in comparison to the rest of that 2D graph. So here's our first one. We have that irregular / non-zero scale that I was talking about, and the way we're going to fix this is we can keep that 40 at the bottom, but it does mean that every tick mark from there also has to be a value or a multiple of 40. What it also means, if you didn't notice before, but the personal vehicles, it was kind of in the high 80s area, it means that all of this gets shrunken down, and now we have about that 80. And we can see more clearly now that the students that go through public transport versus a personal vehicle, the difference is only about half, as opposed to what looked like maybe even 4 times that amount from the graph before. Next, we have a graph without a scale, right? So we're going to begin by adding in these tick marks and talking about frequency. Without the frequency, we can't really understand what is going on with this graph, like how many units, observational units, are we looking at falling into each category. We're also missing some elaboration on what we're really looking at here. I'm just going to give it to us. We're looking at handedness. We're going to ignore ambidextry for now, and let's just say that we're going by multiples of 5 here. They are evenly spaced out, so we are in the clear. And now we can see comparatively, we have that many left-handed ones and we have that many right-handed ones. And now they have an association in our brains with a numerical value, as opposed to just saying, oh, there's a lot of right-handed people and a little bit of left-handed people. Now we can really see that difference more clearly. Now for different box sizes, right? I mentioned before where our eyes, we want to see things that look the same, and it makes it just easier to compare. Right? If we look at the height of these boxes, which is what we are supposed to be doing, right? We see that the heights are not very different at all. However, on an initial glance, we're going to see that, oh, the box for dogs just is bigger. It takes up more area. Therefore, this amount of people who prefer dogs must be significantly more than cats, but this is not really the case, right? So we're just going to chop off some of this box so that they're about the same size once again. And now it's a lot easier to look at them and say, oh, yeah, there's more people who like dogs, but it's not really by a crazy amount. And our last section, which is having a 2D graph with a section pulled out, right? We see here number of units that students take, and most students are going to take 12 to 15 in order to graduate on time, blah, blah, blah. But only a tiny amount of students, right here, are going to be taking 19 plus units, right? And that's a tiny sliver compared to all the other chunks that I have listed out here. However, now that we've pulled out this chunk for 19 plus units, it's been blown up and it no longer really fits into that space. So it looks a lot larger. It looks like there are far more students within that category than there really are. A better way to kind of represent this would be to have our graph. And if we need to emphasize a particular area, what we could just do is probably maybe just highlight that area and do it that way without pulling it out of proportion. We could also just pull it out, but we would have to, like I said, keep it in proportion to how it was in the graph, as opposed to blowing it up like I have in this example here. Here are some examples of pretty good graphs. So these are both from the New York Times website, and this one has a good title: Smokers Every Day Based Off of, or Some Days Based Off of Household Income. All right, we have our household income brackets, our bins here, and we're looking at percents. It doesn't have it labeled for each one because we're expected, since we see that first one, to just kind of roll with it, that each of them are percents, not individual counts of people. I like this one also because down here in the subscript, we see explanations for those who may not be familiar with the shorthand or are inquisitive in regards to how this income is calculated. So moving on, another graph that was great that I found on the New York Times website is talking about the amount of women in the essential workforce, right? So right here we have all essential workers, and if we total up everything down here, we are going to result with this total workers right here. This is just a good way to spread out our data so that we're not having a stacked bar graph that has really tiny, way too many colors and really tiny boxes within where we can't really tell the difference. I also like this one because we can see the comparison of the percentages into a whole, right? We have, it's roughly proportionate, and we don't have any values that are significantly seeming larger than everything else. That does not have the numerical or proportional values to back it up. So in my final reflection here, the things that I learned about misleading graphs is that we need to double check our graphs, because if we allow our eyes to just kind of glance over and expect that the graph is telling us exactly what we need to know, we are going to miss things, and we may end up with understanding data that is out of proportion from how it should be, or just making wrong inferences because we do not have an accurate way of measuring variables against each other due to the misleading graph. And to fix these up, right, we just want to make everything as even and proportional as possible to each other, as well as clear as possible for anyone looking at the graph to understand without having problems of wondering what is going on, or not understanding how we are measuring our data.